Good morning. Let's talk about rotations, the next lesson in the transformations objective. So first of all, a rotation, you probably think of going around and around. For a 3D object, a rotation is to go around an axis, all right, to go around an axis, all right? This is how you create, for example, if you have a rectangle and you rotate it around an axis, you create a cylinder, all right? We're gonna focus on two-dimensional. So we're gonna rotate around a point, all right? And to start, we're gonna rotate around the origin. Okay, so let's get right to it. We're gonna continue with a pink pre-image and a blue image, all right? And so here is an example of a rotation. If the pink one was the pre-image, think about how far you've rotated this blue image. So there's a couple of answers right here. You can either think of it as it was a counterclockwise rotation, meaning going against the clock, all right? Or you can think of it as a clockwise rotation, right? Now, if this was clockwise, you rotated it, well, let's think about it. So let's look at an animation of this rotation, all right? If I animate it, I rotated it 90, 180, 270 degrees counterclockwise, all right? One more time, it went 90, 180, 270 degrees. If it would have rotated 300 degrees, 360 degrees, then it would have been back at the original position. All right, so let's take a look at how you can visualize a rotation. All right, the first thing is you can visualize the center of a circle being at 0, 0, and the radius of that circle touching any of your points on the pre-image, on the pink pre-image. All right, then you can imagine a line from the point on your pre-image to the center of the circle. All right, then you can graph, and this line, you could represent it as your starting point, all right? Then you can draw a perpendicular line, all right, to that first one, perpendicular meaning opposite reciprocal slope. Notice how my first line has a slope of -2/1, while my second line has a slope of up 1/2, all right? So you can tell they're perpendicular. Now that you have two perpendicular lines, you can tell that what we're doing is we're thinking of this as our starting point or 0-degree rotation, all right? As you go clockwise, this would be 90 degrees of rotation. As you continue going, you're now at a 180-degree rotation, 180 being, a line, all right? If you continue another 90 degrees, you'll be at 270 degrees clockwise, all right? Which is actually the same as going 90 degrees counterclockwise. Okay, so that is the transformation. So what do we have to learn about this? Well, now that we understand what our angles of rotation are, we need to understand also that there are rules for your coordinates. So a pretty neat thing happens right here. If I keep track of this point, which is -1, 2, and I think about where it transforms, so if I go 90, 180, 270, its new location is at -2, -1. Look how similar those 2 points are, all right? It looks like the numbers swapped places, but my y became negative. Let's verify if that's true for all points. So I'm going to choose the point right here, 3, 8. And if I go around 90, 180, and then 270, I notice that the point now becomes -8 and -3, all right? -8, -3. So by the way, this was -3, 8. Okay, so you notice that your x swapped places with your y swapped places with your x, but the y became negative. All right, so therefore every coordinate in the pre-image, which was x, y, has now become, well, again, it switched places, a y, x. However, the y has switched sign, so it is now -yx, and that would be what I call my rule. My rule for a 270 degrees rotation clockwise. Okay, now 270 is only one of the rotations that you could have. So actually we have multiple rotation rules for these. All right, so if I check this out, I'm going to check out this image. All right, with the time that I have left, I have a few rules that I could follow. All right, and this table, check it out on your own time, outlines all the rules for rotations. You can switch your x's, your y's, your signs. Those are the rules.